Algebra 1, Unit 8B Study Guide, solving quadratic equation problems using radicals or by taking the square root of both sides, including those that might use the Pythagorean theorem. So the first problem is x squared plus 8 squared equals 10 squared. So sometimes you just have to think of order of operations and do the math. So we'll take care of the exponents first. 8 squared is 64. 10 squared is 100. Now we want to get x by itself, so we're going to subtract 64 from both sides. And then finally, when we have the x squared by itself, we can take the square root of both sides. The square root of 36 is 6, but we want both the positive and the negative case. So we want both answers, both solutions. Our second problem is identical. We just first of all start out with those exponents because we don't have any parentheses. So 3 squared is 9 plus x squared equals 16. Subtract 9 from both sides, so x squared equals 7. Now we want to get x by itself, so we undo the square by taking the square root. So we do not have an even square root of 7. We don't want to estimate, get on our calculator, so we simply leave our answer as the positive and the negative, plus or minus, square root of 7. On this next problem, it seems almost the same, but notice you've got numbers all on the left side of that equal sign. So we'll just do the math. 3 squared is 9, 4 squared is 16, and that equals x squared. We combine 9 and 16, and then we take the square root of both sides. So x will equal positive and negative 5. Square root of 25, which is 5. On the next three problems, we'll just continue. Notice we have 1x squared plus another x squared. So that gives us 2x squared. So that's the first thing that we want to simplify. So 2x squared equals 100. Divide both sides by 2. So x squared equals 50. Take the square root of both sides, and then let's simplify the square root of 50. It breaks down into 2 times 25. 25 is a perfect square. So if we take that square root of 25, 5, it comes out front, but first we want to write our plus or minus 5, which is the square root of 25, and 2 stays underneath because we're not able to evenly take the square root of 2. On our next problem, we've got 5 squared, which is 25, plus x squared equals 6 squared, which is 36. Subtract 25 from both sides, so x squared equals 9. Take the square root of both sides. I'm sorry, that is not quite right. That equals 11. There we go. Take the square root of both sides, so x equals, we can't simplify the square root of 11, so we will simply leave it in square root form and have the plus or minus case. On this problem, we need to square the 3, and then square root of 5 needs to be squared, 4, and x. So this becomes 9 times 5. 9 times 5 is 45. So I'm just thinking of order of operations. I took care of exponents first, then multiplying. Now I'm going to add, so 49 equals x squared, and take the square root of both sides, so x equals positive and negative 7. And this problem with the right triangle, draw yourself a picture. So it has a leg, that's one of the sides that makes up the right angle of 5 and a hypotenuse of 8. Write an equation that we could use to find that missing length. Well, remember the Pythagorean theorem. A squared plus b squared, those are the length of the legs, equals c squared, and that's the hypotenuse. So we'll call the missing leg x. X squared plus 5 squared equals 8 squared. Now it's just like the problems that we've been doing. So we'll square the 5, we'll square the 8, subtract 25 from both sides. So x squared equals 39. Just to check that. And we'll take the square root of both sides. And I'll put the answer up here. So x equals positive, I'm sorry, this is a length. So we only want the positive case. So the square root of 39.